So this is page 454, and we're doing 69 to 99 odd, but we're going to skip 75, 77, and 85. So skip those. All right. Yeah. Okay, 454. 454 is right after 453 and right before 455. She's not listening. Caitlin, it's right after 453 and right before 455. All right. So, number 69, glide path of a commercial jet airliner. If a commercial jet liner is 5,000 feet ground distance from the runway, what should the altitude of the plane be to achieve 2 red and 2 white lights? Assume that it corresponds to a 3-degree glide path. So this is how airplanes know if they're on track to hit the runway. Right? There are lights. So they have this little machine that sends lights like this, and the airplane wants to follow this glide path, so it wants to only see those 2 lights. If it sees the wrong lights, then it needs to, if it sees too many on one side, it needs to drop faster. If it sees too many on the other side, then it needs to rise. And the job of the pilot is to just descend at that constant 3 degrees so that it sees the right lights all the time. It makes landing a whole lot easier because the lights do most of the work for you. Okay? So we have this 3 degrees, and we know that the airplane is 5,000 feet from the runway, and we want to know how high does the airplane need to be when it's 5,000 feet away. Well, what trig function would I use? Tangent. So the tangent of 3 degrees is equal to opposite over 5,000. Is that a multiply or a switch? Multiply. So I multiply by 5,000. So 5,000 tangent of 3. We end up with 262 feet. Okay. All right. Do you need any help with 71? It's the same basic problem. We good with 71? Okay. 73, search and rescue. If the search and rescue helicopter is flying at an altitude of 150 feet above sea level, what is the diameter of the circle illuminated on the surface of the water? So we have a helicopter. Beautiful. And it's sending down a searchlight, which creates a circle down here. And this angle right here is 30 degrees. And we want to know if the helicopter is 150 feet above sea level. So from here to here is 150. What is the diameter of the circle? We want to know how big this is. How would we do that? Well, we always need a right triangle. So here is the right triangle, and I'm going to move it over. What do I know about that triangle? This is 15 degrees, and the height is 150, and I want to find the opposite side, tangent. Tangent of 15 is equal to opposite divided by 150. Is that a multiply or a switch? Multiply. So 150 tangent of 15 degrees gives me 40.19 feet. I need to double it because I want to know the entire length, not just half of it. So we multiply this by 2, 80.38 feet. Okay. All right, we skipped 75 and 77. Do we need help with 79? Anybody want to see 79? Okay. So one thing that you should know, angle of elevation and angle of descension. So if you look straight and then you tilt your head back, you would create the angle of elevation. If you tip your head forward, you would create the angle of descension. So angle of elevation is the rotation needed to go from flat up. And then the angle of descension is flat down. So in this case, we're using the angle of ascension, which means we would have a triangle that looks like this. And we know that this says angle of inclination, of a mountain with a triple black diamond ski trail is 65 degrees. If a skier at the top of the mountain is at an elevation of 4,000 feet, how long is the ski run from the top to the base of the mountain? So we know that this is 65, and we know so I guess we're assuming we're going to start at the top of the mountain and end at sea level, right? I mean, it says the elevation is 4,000 feet. It doesn't say 4,000 feet above the base of the mountain, but that's probably what it means. And which side do we want to know? The hypotenuse. So what trig function would we need to use? So the sine of 65 is 4,000 over h. Is that a multiply or a switch? We switch those. 4,000 divided by the sine of 65. So the ski run is 4,413 feet. Is that what the back of the book said? 4413? Oh, they rounded it. That 6-inch difference is a big deal. Oh, okay. Round to the nearest foot. All right. 81. Do we need help with 81? Yeah. Well, I'm not going to draw this picture. All right, number 81. The structure of molecules is critical to the study of materials science and organic chemistry and has countless applications to a variety of interesting phenomena. Trigonometry plays a critical role in determining the bonding angles of molecules. For instance, the structure of dibrometetrachloride ferrate, the third, is shown in the figure below. Why would the shape of molecules be so important? Yeah, the different structures have different physical properties, and different structures fit together in interesting ways. If you take a cup of water and you take a cup of like rubbing alcohol and you mix them together, you end up with less than 2 cups of liquid because of how the molecules fit together. It's kind of like saying if you had a cup of walnuts like in their shell and a cup of M&Ms and you mixed them together, would you end up with 2 cups of walnuts and M&Ms? No, it'd be less than that because the M&Ms fit in the gaps of the walnuts. And the same thing happens with alcohol and water. Right. So if you had, you know, a giant container of big rocks and a giant container of small rocks, and you mix them together, will you have two giant containers? No. So anyway, the structure of molecules is very, very important. 81. Determine the angle theta, the angle between the axis containing the apical bromide atom, of course, and the segment connecting the bromide to chloride. So angle theta right there. Oops. This one. So we have a right triangle right there, and we have two sides of that right triangle. So I can figure out this angle here. How would I find that angle? Tangent. Tangent inverse of 2.219 over 2.354. So the tangent inverse, oops. Divided by 2.354. Now, I get 43.3, but that's not what I want. 180 minus this because those two angles are supplementary. Oops. I sure did. Minus 43.309. So 136.69. Okay. 83. Two neighborhood kids are planning to build a tree house in tree 1 and connect it with a zip line to tree 2 that's 40 yards away. The base of the tree house will be 20 feet above the ground and a platform will be nailed into tree 2 3 feet above the ground. The plan is to connect the base of the tree house on tree 1 to an anchor 2 feet above the platform on tree 3. How much zip line will they need? Here's the picture. So we basically have this right triangle here, and we just need to find the dimensions of that. What is the base of this triangle? 40 yards. Oh, good. And then the height is, it's not 20, it's actually 20 minus 2 minus 3. So 15 feet, which is 3 yards. No, wait, 5 yards. Oh, we'll convert it back. Okay, I don't need trig to figure this out. It's just going to be 5 squared plus 40 squared, and then raise that to the 0.5, and that's in yards. So I need to multiply it by 3, 121 feet. Right? Okay. Do you need any help with 85? Oh, we skipped 85. Okay. 87. Do we need help with 87? No? Okay. 89. That's an easy one. All right. And then, did we go to 89 or 99? We went to 99. All right. So 91. Oh, that's easy. 91's pretty easy. 93 is pretty easy. 95. If you are given the measure of two sides of a right triangle, you can solve the right triangle, meaning you find everything else. Yes. What's the minimum you need? Two sides works. What else works? An angle and a side will work. What about two angles? No, because right. Well, actually, you know the proportions, but you don't know the lengths, right? So if I gave you a right triangle and said 30 and 50, you know what the proportions are. You just have to do the inverse sine or the inverse cosine or inverse tangent. But how many triangles are there that fit that definition? An infinite number. Big ones, small ones, medium ones. So you need at least one side, and then you need another side or another angle, and that will be enough. Okay, 97. If you are, what's that? 97. If you are given the two acute angles of a right triangle, can you solve? Oh, hey. No. You need at least one side. And 99. Approximate the sine of 0 without using a calculator. So we did this a couple years ago if you were in my class. So sine is opposite over hypotenuse. And as this angle gets smaller, what happens to O? It gets smaller. So basically we have a small number divided by the hypotenuse. If this keeps getting smaller, then we're going to approach 0. What about the cosine? So so in this case, the hypotenuse is getting shorter, and the adjacent isn't changing. So the adjacent stays where it is, and the hypotenuse is approaching the adjacent. So the cosine is approaching 1. Because when you have a 0-degree angle, the adjacent and the hypotenuse are actually the same length. Right? They're the same distance. Right. All right.